Warm and heartfelt greetings from Manipal to one and all attending the function. Welcome to the International Conference on Combating Antimicrobial Resistance. World Antimicrobial Resistance Week is celebrated every year between 18th and 24th of November. This year's theme is Spread Awareness, Stop Resistance. Let's begin with some poetry, shall we? Here goes. Many antimicrobials that worked before don't seem to be as effective anymore. Prescription compliance errors are an open door to antimicrobial resistance galore. Bugs mutate, develop special traits, and adapt over time to resist and tolerate. Hence, appropriate steps let's all undertake to spread awareness, stop resistance, and make this problem abate. Now, antimicrobial resistance is a global health and development threat. WHO has declared AMR as one of the top 10 global health threats facing humanity. The events that lie in store for us the following week are centered largely on the mentioned theme. So, let's all gear up for an eventful, exciting, and educationally enriching week. I now request our organizing chairperson, Dr. Kavita Saru, professor and head of the Department of Infectious Diseases, Kasturba Medical College, Manipal, to escort the dignitaries onto the stage. We have with us on a stage the chief guest for this function, Lieutenant General Dr. Venkatesh, who is the Vice Chancellor of Kasturba Medical College, Manipal. We also have with us Dr. Sharat Kumar Rao, Dean of Kasturba Medical College, Manipal, and Dr. Avinash Shetty, Medical Superintendent of Kasturba Medical College, Manipal. Our guest of honor, Professor Ramasubramanian, is attending the function online. He is the director of the Capstone Clinic and consultant in the Department of Infectious Diseases and Tropical Medicine of Apollo Hospitals. He is also an adjunct professor of infectious diseases in various educational institutes in Tamil Nadu, namely Sri Ramachandra Institute of Higher Education and Research, the Tamil Nadu Dr. MGR University, Savita Medical College, and Apollo Hospitals Educational and Research Foundation. It is a privilege to have you attend this function, sir. And we are extremely grateful to all the dignitaries for accepting our invitation and taking time out of their busy schedules to attend the function. I would now like to call upon Dr. Sharat Kumar Rao to give the welcome address.
Thank you, Dr. Anaga. A very good afternoon to each and every one of you. As you all know, World Antimicrobial Awareness Day is celebrated, Awareness Week is celebrated globally in every country between 18th November to 24th November. Celebrated annually, World Antimicrobial Awareness Week aims to increase awareness of global antimicrobial resistance and to encourage best practices among the general public, health workers, and policymakers, mainly to avoid further emergence and spread of drug resistance infection. As you all know, the theme of 2021 is Spread Awareness and Stop Resistance. Department of Infectious Diseases, along with pharmacy practice, emergency medicine, MAC-ID, have arranged for a week-long program, along with talks, deliberations, and community outreach activities. Manipal College of Pharmaceutical Science is arranging competitions among the students. A photo and video booths are arranged in OPD and in front of the infectious disease department where anyone can have a photo or a video with a message creating awareness about antimicrobial resistance. Go Blue is the theme for antimicrobial resistance. Because of this, 24th November, KMC will be lit in blue color. For this function today, we have around 600 registrants from all over India and the world. It's my first duty to extend a very warm welcome to them. Honorable Vice Chancellor of MAHE, Lieutenant General Dr. M.D. Venkatesh, is the chief guest of today's function. A honorable welcome to you, sir. Guest of honor, Dr. Rama Subramaniam, who is the director of the Capstan Clinic, and he is also the president of Clinical Infectious Disease Society of India. He'll be joining us online. I thank him for taking time out in his busy schedule, and a very respectful welcome to you, sir. All the faculty, students, and other healthcare workers who have joined here physically, I extend a very cordial welcome to you. Thank you very much.
Light, as a symbol of knowledge, removes ignorance and is a lasting wealth by which a lot can be attained. To mark the beginning of the plethora of events that are to unfold this week, I request the dignitaries on the stage to light the lamp. I now call upon Dr. Karvita Sarvu to give an overview of the program.
Esteemed Chief Guest, Lieutenant General Dr. Venkatesh, respected Dean, Dr. Sharath Rao, Admirable Medical Superintendent, Dr. Avinash Shetty, and our guest of honor, Dr. Ram Subramaniam, invited guests, dear students. It gives me immense pleasure to give you overview of today's program and World Antimicrobial Awareness Week program. We have witnessed from the end of 2019 what a pandemic can do to us, to our lives and our livelihood. Antimicrobial resistance is an evolving pandemic and is just as dangerous. Recognizing this threat, a global action plan was endorsed at World Health Assembly in 2015. The strategic action objectives are: one is to raise awareness and promote behavior change. Second is global surveillance and research. Third is preventing the incidence of infection by adopting efficient measures to prevent infection and efficient use of water and sanitation. Optimizing the use of existing antimicrobials both in human and animal health, and investment and R&D in antimicrobial resistance. So in 2015, World Antibiotic Awareness Week was being observed to promote awareness about this problem. In 2015, the scope of this was expanded to include antimicrobials so that a more inclusive global response can be achieved, engaging a lot many stakeholders. So befittingly, we from the Department of Infectious Diseases have partnered with various departments, especially Department of Emergency Medicine from Kasturba Medical College, Manipal, Departments of Medicine and Microbiology from Kasturba Medical College, Mangalore, Department of Pharmacy Practice from Manipal College of Pharmaceutical Sciences, encompassing multiple disciplines in our campus. And this international conference is one of the programs to raise awareness about this antimicrobial resistance. As Dean has already mentioned, we have other campaigns such as Going Blue campaign in the campus at an individual level and as an institution, where we express solidarity towards awareness about antimicrobial resistance by Going Blue. And also, for any public health initiative to be successful, we need community engagement. And Dr. Sonal from Manipal College of Pharmaceutical Sciences is in the forefront to raise community awareness about this problem by engaging the community, students, and by engaging or conducting various competitions. One of the objectives is surveillance and promoting research to combat antimicrobial resistance. Manipal Center for Infectious Disease has been in existence for more than 6 years, and we have been able to deliver on our promises to stimulate research and promote ID education in Manipal. We have been able to transform Division of Infectious Diseases in the Department of Medicine into Department of Infectious Diseases with the support from the leadership. As a center, our members have been able to publish their seed grants in good publications, good journals, and we have been able to secure grants from ICMR, Science and Engineering Research Board, and DBT. Also, some of the members have been partners in various international funds. We have been collaborating with reputed institutes in India, CMC Vellore, All India Institute of Medical Sciences, and also we have international collaborations, to name a few, Menzies in Australia, Charité in Germany, Mayo Clinic, and Yale University. Also we have with Wayne State University, who are our main partners in this conference. We have McGill University from Canada. So we have been partnering with these institutions over the years, and it's a win-win situation to both of us. I must acknowledge the contribution of MACAD Core Committee members, Dr. Shrikala Baliga, Dr. Murli T.S., Dr. Kiran Chawla, and Dr. Sneha Malya, who have been my advisors during my journey in taking MACAD to this position. Also, I would like to acknowledge contributions of Dr. Murlidhar Verma and Dr. Nitin Gupta in building the Department of Infectious Diseases. I have received support from many corners across the departments, across campuses, institutions, and across the borders. I'm grateful for this. Also, I'm grateful to the MAHE leadership in reposing their trust in my abilities to, and also I seek similar support in future endeavor. Coming back to the theme, misuse of antimicrobials puts us all at risk. They must be handled with care. I hope this conference generates enough awareness and motivates us all to act in the direction so that we preserve these magic bullets called antimicrobials for our own future. Thank you. Moving on, it's my pleasure to announce the MacAdie Best Publication Awards for the year 2020-2021 to encourage the researchers of MAHE to publish high-quality original work in the field of infectious diseases. MacAdie has been giving awards for the best publications in the field of infectious diseases. Papers are selected based on the relevance of the research work, the publication impact factor and the quartiles, collaborative and interdisciplinary nature of the work, and the patents filed and contributions to the society through technology development. These have been reviewed by 3 reviewers. It carries a certificate and a prize money of INR 5,000. I would like to first thank the reviewers, Dr. Santosh KV, Deputy Director, Research, Dr. B.S. Satish Rao, Directorate of Research of MAHE, and Dr. O.C. Abraham, CMC Vellore, for reviewing these publications. I would like to request our chief guest to award these MacAdie Publication Awards. One publication award goes to Dr. Naresh Kumar Mani, Associate Professor, Department of Biotechnology, MIT Manipal, for his work inkjet printing of paraffin on paper allows low-cost point-of-care diagnostics for pathogenic fungi, published in journal Cellulose, which is a Q1 journal, impact factor 5.2. Another MacAdie Best Publication Award goes to Dr. Ujjwal Verma, Associate Professor, Department of Electrical and Communication Engineering, for the paper Thread Integrated Smartphone Imaging Facilitates Early Turning Point Calorimetric Assay for Microbes, published in the journal RSC Advance, which is a Q1 journal, impact factor 3.64. On behalf of Ujjwal Verma, his co-author Dr. Prakash from the Department of Microbiology, KMC Manipal, will be accepting the award. Thank you, sir, for awarding the awards, and congratulations to the awardees.
Thank you, ma'am. Up next are appreciation awards that will be handed out to well-deserving doctors for their commendable contribution to making this week a success. I request Dr. Avinash Shetty to present the awards. The awardees are as follows. Dr. Sonal Shekhar M. from the Department of Pharmacy Practice, Manipal College of Pharmaceutical Sciences, receives an appreciation award for organizing community outreach activity during World Antimicrobial Awareness Week. Dr. Nitin Gupta, Assistant Professor in Department of Infectious Diseases, Kasturba Medical College, Manipal, receives an appreciation award for organizing an antimicrobial quiz for the students. Dr. Prithvi Shri Ravindra, Assistant Professor in Department of Emergency Medicine, Kasturba Medical College, Manipal, receives an appreciation award for leading social media campaign during the World Antimicrobial Awareness Week and for organizing quiz competition for the students. Thank you, sir, for presenting awards, and congratulations to all the awardees. I would now like to invite our guest of honor, Professor Ramasubramanian, to enlighten the audience with his words.
Good afternoon, everybody. It's indeed my pleasure and privilege to be representing the Clinical Infectious Diseases Department on the inauguration of the International Conference on Combating Antimicrobial Resistance, which is being held in connection with the World Antibiotic Awareness Week. When I think back of the journey I have had in the field of infectious diseases over the last more than 2 decades, I still remember that when I came to India, there were very few pioneers in infectious diseases. We had George K. Verghese, Dr. Dilip Mathai, Dr. O.C. Abraham, but infectious diseases as a field was conspicuously lacking in most parts of India. At that time, I did not understand the reason why a country where almost 60% of a practice involved infections and management of infectious diseases, there was a dearth of infectious diseases practitioners. It was later when I came across Stephen Hawking's words that the greatest enemy of knowledge is not ignorance, but is the illusion of knowledge, that I understood the reason. Because most practicing physicians and clinicians in India have the illusion of knowledge, unfortunately, because they see infectious diseases every day. They feel that they can handle and manage. And the development of Clinical Infectious Diseases Society was held as a start to this situation and how to address the problem. So as it says, it was spreading awareness and stopping resistance. So I think it is the responsibility of all of us to ensure that infectious diseases is practiced in the correct manner, ensure that we spread the knowledge. And I congratulate Dr. Kavita Saravu, who's spearheading the initiative in Manipal. I wish a lot of success for the Mangalore chapter of the Clinical Infectious Diseases Society and hope it will reach greater success. I wish the conference all success and hope the Antibiotic Awareness Week is celebrated well and to the satisfaction of everybody. Thank you.
Thank you, sir, for those wonderful words. I would now like to call upon our chief guest, Lieutenant General Dr. M.D. Venkatesh, to address the gathering.
Good afternoon, everybody. I bring you warm greetings from Manipal Academy of Higher Education, an institution of eminence deemed to be university. Dr. Ramasubramanian, Dr. Sharath Rao, Dr. Avinash Shetty, Dr. Kavita Saravu, and the multidisciplinary organizing team of this international conference and Awareness Week, all faculty who are present here, students, online delegates, and all other guests and attendees. That antimicrobial resistance is a scourge of the world is now more than evidently proved across the globe, not only in India, in places of healthcare practice, but also in the community. To this end, antimicrobial resistance has been declared as one of the top 10 public health threats to humanity by the World Health Organization. Today, antimicrobial resistance kills 1 person every minute. It's a very complex problem that requires united multi-sectoral approach. That antimicrobial resistance is a global health and developmental threat, and it impacts the achievement of sustainable development goals, and it requires multidisciplinary, multi-sectoral approach is something which has been understood by all the people who are involved in this field of antimicrobial resistance. Some of the reasons for which there has been an accelerated threat is one, overuse and misuse of antibiotics, widespread use of antibiotics in livestock, poultry, agriculture, some poor diagnostic and prescription practices, inadequate infection control, and non-adherence to evidence-based practice of medicine, and public health issues like hygiene, sanitation, and non-availability of clean drinking water. That it is definitely something which we all should be worried about. And therefore, in the year 2015, a global action plan to tackle antimicrobial resistance was initiated by WHO, FAO, and the World Organization of Animal Health. And jointly, it was called as a One Health approach. All of us who have been in the field of healthcare and practicing clinicians have known the havoc that an antimicrobial resistance can cause. And therefore, this Awareness Week, which is practiced or which is celebrated or which is utilized to spread awareness between 18th and 24th November every year, is a very, very important event and should become a very important event in the calendar of any healthcare institution and the community serving institutions. This year's theme is to spread awareness and stop resistance is absolutely apt, and I'm sure this entire week with the myriad of activities with Dr. Kavita Saravu and her team and with all other participating departments and university abroad, that's the Wayne State University, will achieve its stated objective of creating awareness and also bringing in an urgency into tackling this issue. As we celebrate the World Antimicrobial Awareness Week, I urge all the institutional heads and the policy makers to strengthen the antimicrobial surveillance and ensure that the policies which are there, which are well enunciated, are practiced in its true sense, and we also have newer policies to regulate the use of antimicrobials more judiciously. This is not a one-off event. This has to become a moment, and it has to be internalized, and all those people who are practicing medicine, who are in the industry of animal husbandry, poultry, agriculture, and also in the field of public health. Therefore, it needs a much concerted action from across sectors, and I'm sure over a period of time, this awareness increases, we get into better practice and better use of, more judicious use of antimicrobials, and reserve the best available antimicrobials for the most severe infections. And I wish this Awareness Week all the success, and this international conference and its delegates a very, very enriching academic and learning experience. Thank you very much, and Jai Hind.
Thank you, sir. That was truly a splendid speech. Dr. Sneha Deepak Malya, Associate Professor, Department of Community Medicine, Kasturba Medical College, Manipal, and Core Committee member of MAC-ID, will now propose the vote of thanks. Over to you, ma'am.
Honorable Chief Guest for today's program, Lieutenant General Dr. M.D. Venkatesh, Vice Chancellor Mahe Manipal, Guest of Honor Dr. V. Subramanian, Senior Consultant in Infectious Diseases, HIV and Tropical Medicine at Apollo Hospital, Chennai, and also President of Clinical Infectious Disease Society. Dr. Sharath K. Rao, Dean KMC Manipal, Dr. Avinash Shetty, Medical Superintendent of Kasturba Hospital, our most valued resource persons, ladies and gentlemen, it's my privilege to propose the vote of thanks on this occasion. On behalf of Organizing Committee of International Conference on Combating Antimicrobial Resistance, organized by Department of Infectious Diseases, KMC Manipal, and MACID MAHE, and all the other organizing supporting departments, I extend a hearty thanks to our chief guest, Lieutenant General Dr. M.D. Venkatesh, for gracing this occasion, providing the inaugural address, and also awarding the MACID Best Paper Awards. Thank you, sir. We thank our guest of honor, Dr. V. Subramaniam, for being with us and also providing the valuable message for this cause. Thank you, sir. We are grateful to our Dean, KMC Manipal, Dr. Sharath Rao, for giving the welcome address and providing all the necessary support for organizing this event. Thank you, sir. We are thankful to Medical Superintendent of Kasturba Hospital, Dr. Avinash Shetty, for providing all the support with all the resources and also providing the video message. Thank you, sir. We are truly indebted to all the MAHE leaders who have given out their video messages for spreading awareness about antimicrobial resistance. Thank you. We are also thankful to our Associate Dean, Dr. Krishnanand Prabhu. Thank you, sir, for your presence here. We are thankful to all the resource persons of this 5-day-long conference with specific mention of the 3 eminent speakers for today's program, Dr. Kamini Walia, Dr. Balaji, and Dr. Senthur Nambi, and all the other speakers who will be joining us in the coming days. Thank you. I also thank Dr. Kavita Sarau, organizing chair of this conference, for taking the lead and planning out this mega event. Thank you, ma'am. We are also thankful to Dr. Chandrasekhar, Chief, Division of Infectious Diseases, Wayne State University, USA, who is our international partner for organizing this event. Thank you, sir. Special thanks to our partners from the institutions under MAHE, Dr. Damodar Shanay from KMC Mangalore, Dr. Suchitra Shanay, HOD Microbiology from KMC Mangalore, Dr. Mahadev Rao, HOD Department of Pharmacy Practice, MCOPS, Dr. Jayaraj, HOD Department of Emergency Medicine, KMC Manipal. Thanks to all of you. We are thankful to Dr. Sonal Shekhar and Pharmacy Literacy Club for organizing the very important community educational activities and organizing the student competitions. Thank you. Dr. Nitin Gupta and Dr. Prithvi, who organized the antimicrobial quiz. Thanks to both of you. We are grateful to the MACID core committee members, Dr. Kiran Chawla ma'am, Dr. Shrikala Baliga, and Dr. Murali TS for guidance for organizing this event. Thanks to Mr. Sachin Karan and his team from Manipal Health Enterprises for the logistics and other arrangements. We also thank the hospital IT department for providing all the necessary support for organizing this event. Thanks to Ms. Priya and Tripti, who are the center managers, for organizing the helping in organizing this particular event. We are grateful to all the industry sponsors who have contributed for this event. I also thank Ms. Anagha, who is the master of ceremony for today's program. Thank you, Anagha. Thanks to each and everyone for being with us today. Thanks a lot for joining us here with the physical presence, and all the delegates who have joined us online. Thank you very much for joining us. Have a pleasant day. Thank you.
That brings us to the end of the inaugural function. I request the dignitaries on the stage to kindly accept our mementos, symbolic of our appreciation and gratitude. Okay. I request the dignitaries on stage to kindly take their place among the audience.
Let us start the scientific session of the day. At the outset, I welcome all the participants who are attending this session, whether they are offline or online. Myself, Dr. Kiran Chawla, professor in the Department of Microbiology, KMC Manipal, and
I'm Dr. Ravi Raj, Professor and HOD of Department of Medicine at KMC Manipal.
will be the moderators for today's program. So, for the speakers, I just have one announcement. There will be 25-minute talks, and after that, 5-minute discussion will be there. So, I request all the speakers to stick to their time. Now, let us start with the first talk on burden of multi-drug resistant organism in India. We all know to fix any problem, it is very important first to know what is the problem and what is the extent and spread of that problem. Today, emergence of multi-drug resistant organism is the major challenge that mankind is facing. These MDROs need special attention because they can leave the clinician with no choice of antibiotic to manage the patient, and at the same time, they will increase the hospital stay, the cost of hospitalization, and even the morbidity and sometimes the mortality for the patient. To discuss the exact burden of these MDROs in India, there can be no better person than Dr. Kamini Walia, today's speakers for the talk. Dr. Kamini Walia, she is a microbiologist by training, and subsequently she has trained in public health from Johns Hopkins University. Currently, she is working as a senior scientist in the Division of Epidemiology and Communicable Diseases at Indian Council of Medical Research, New Delhi. Dr. Walia is currently Program Officer for Antimicrobial Surveillance Network of ICMR and coordinating the activities of Antimicrobial Stewardship Program for India. She has expertise in infectious diseases, including HIV and AIDS program, and development of infectious disease diagnostics and vaccines. She has, through her initiatives, always supported collaboration with other public health partners in the public health space, and she was instrumental in initiating the collaboration of ICMR with NIH. She has 69 publications to her credit in various peer-reviewed journals. She, along with the support of other team members, has spearheaded the publication of AMR surveillance, which was done for 1 year in 2018. So I request Dr. Kamini Walia to please share her knowledge about the burden of MDRO in India now. Let us listen to her.
Good afternoon, everyone. I hope you are able to hear me. Am I audible?
Yes, ma'am.
Am I audible? Okay.
Yes, yes.
Okay, I'll share my screen. Just tell me when you are able to. So are you able to see my screen now?
Yes, it is visible. It is visible, ma'am.
Okay. So good afternoon, everyone. And I really, at the outset, would like to thank the organizers for giving me this opportunity to share the ICMR perspective on this very important public health challenge of antimicrobial resistance. ICMR has been committed to this initiative for a long time now. And as previously mentioned in my introduction, that we have an AMR surveillance network as well as with the support of many ID physicians spearheaded by Dr. Ram Subramaniam. We are also coordinating the antimicrobial stewardship initiative from India. So multi-drug resistant pathogens are a very important public health challenge, and I am happy to share some of my views and perspectives which are supported by data on the importance of MDROs and the public health perspective around multi-drug resistant infections. Now, as we all know, antimicrobial resistance is a very important public health problem because antibiotics, which includes antibiotics, antifungals, and antivirals, which all come under the broad heading of antimicrobials, are foundation of modern medicine. Because the pipeline of new antimicrobials is running dry, so this foundation now seems to be shaking. But we need to remember that development of antimicrobial resistance has been the direct consequence of excessive antimicrobial use, and to an extent that it is now compromising that the gains that we made towards control of infectious diseases. So curbing the increasing trends of antimicrobial use, which is the key driver driving the antimicrobial resistance challenge, would require a One Health approach because of lot of antimicrobials are being used in sectors other than human sector, like livestock, like agriculture, etc. But for the purpose of this talk, I think we will limit the scope of this talk only to the human aspects. Now, as many of you know that there are community-acquired pathogens and then there are hospital-acquired pathogens. Lately, we have been seeing very high increase of drug resistance as well as the incidence of hospital-acquired infections, which are mostly caused by multi-drug resistant pathogens. And these multi-drug resistant pathogens, they are even complicating simple procedures like a transplant or a cesarean section, which are otherwise sterile procedures, and they continue to claim lives as well as lurk in our hospitals as invisible threats, claiming invisible victims. The reason I call them invisible is that first is that we have a poor understanding or the burden of these infections in our country because no agency is actually recording drug resistant infections, and the victims are invisible because again there is no registry of how many people actually lose lives to multi-drug resistant infections. So what are the factors which contribute to development of multi-drug resistant organisms or AMR is that we have increasing incomes and lower drug costs, which improves the affordability of drugs. Then we also have unregulated sale, which leads to increased antibiotic use. There are compromised infection control practices, and to compensate for that, there is excessive antimicrobial cover, sometimes 3, 4, or 5 antibiotics which are given to patients, including antifungals, absence of diagnostic as well as suboptimal stewardship around antimicrobial prescribing. Now, globally, MDROs are being recognized as a major threat to global public health, and they actually impact very critically ill patients with prior antimicrobial exposure or with the existing comorbidity. Infection with MDROs increase mortality, hospitalization cost, and length of stays. Excessive antibiotic use, inadequate hospital environmental conditions, insufficient availability of standard infection control are major contributor to MDROs. And most of the literature which is available on MDROs is from high-income countries, while most of the impact is actually in low-middle income countries where it is understudied. So today I will just would share with you some of the evidence that we have from India as to how the MDRO challenge is unfolding. This data, which I will be sharing with you, comes from the AMR surveillance network, which is functional in 30 hospitals across the country, including KMC Manipal. And we are focusing on improving the surveillance, infection control, and improving the antimicrobial stewardship. Now, these are some of the trends in India, which we publish annually, and the recent report was also released on 2020 data. We see that we have a large proportion of these isolates, which we record in our network. They are constituted by the gram-negative organisms, which includes E. coli, Klebsiella pneumoniae, Pseudomonas aeruginosa, Acinetobacter baumannii, and few others. Now, the ESBL rates are very high, almost 70%, and also we are seeing very high carbapenem resistance rates. Now, these high resistance rates are because most of this data comes from the tertiary care hospitals. That's why we are also reporting increasing MICs and some resistance to colistin as well. What we are seeing is that in Salmonella typhi, the 100%, the MDR is actually down now. We see almost 100% sensitivity to ampicillin, chloramphenicol, cotramoxazole, but increasing resistance to existing drugs, which is fluoroquinolones, as well as cefixime. Also, we are seeing some resistance. Now, in gram positives, 40% MRSA is what we see. There is increasing MIC to tigecycline and linezolid. And this also, gram positives, which includes MRSA and enterococcus, also cause complicated hospital-acquired infections, which are difficult to treat. Enterococcus especially has vancomycin resistance in Enterococcus faecium has increased 3 times in last few years as compared to Enterococcus faecalis. Similarly, we see fosfomycin resistance in almost 12% enterococci. Also, we are seeing the 30 to 40% resistance to caspofungin and fluconazole in Candida glabrata and C. aureus. And we will see why we are seeing this kind of a trend as we go forward. Now, this is the slide which shows that what kind of resistance mechanisms are currently prevailing in the gram-negative pathogens, which are most commonly isolated. As you can see, there are multiple resistance mechanisms, which includes ESBL, carbapenemases, and also the colistin. And there are chances that when these resistance mechanisms are all present in a pathogen at the same time, it becomes multi-drug resistant. This was the profile in the COVID patients that we saw from 10 hospitals. Again, a similar profile, except that Klebsiella pneumoniae was the predominant pathogen, and followed by Acinetobacter, Pseudomonas, and E. coli. Now, coming back to the theme of the talk, which is talking about multi-drug resistance. So, in gram-negative pathogens, MDR is defined when a particular pathogen is resistant to more than 3 antimicrobial classes in the list of these antibiotics, which is aminoglycosides, 3rd and 4th generation cephalosporins, fluoroquinolones, BLBLI, and carbapenems. So if we look at the data for last 3 years, based on this classification, what we see is there is almost 40 to 43% MDR among the E. coli isolates, which are about 25% of the total isolates, which is almost 70,000 to 1 lakh isolates is what we collect through the network. So almost within 25% of those isolates, 40% is resistant. We saw increased MDR in E. coli, which was isolated from COVID patients, around more than 50%, but this one is around 40%. In Klebsiella pneumoniae, there we are seeing increasing trends to MDR in last 3-4 years. And this year data, we are seeing 62% MDR in the Klebsiella pneumoniae isolates. A lot of difference, wide difference rather between the COVID and the non-COVID isolates. COVID isolates having higher MDRs, almost 77% of the isolates are resistant, are multi-drug resistant as compared to the non-COVID isolates. This is Acinetobacter baumannii. This is alarmingly high MDR in Acinetobacter, almost to the tune of 80 to 90%, and now it's at 87 and 88% for this year and the previous year. Then COVID and non-COVID, not much difference except 4-5%. Then in Pseudomonas aeruginosa, the MDR constitutes about 30% of all the resistant isolates. Similarly, not much difference in the COVID and non-COVID. Now let's see what is happening in the XDRs. XDR pathogen is classified as XDR when it is resistant to all the 5 antimicrobial classes. And in E. coli, almost 5 to 7-8% are, this is non-COVID data. But when we go from COVID to non-COVID to COVID, slight increase in terms of XDR isolates from 5.6% to almost 7.5%. Now, the XDR Klebsiella pneumoniae is high. It was almost 14.6% in 2019. It's hovering around 12.14 till now. We still do not have the entire data for this year. Alarming increase in the COVID patients. 42% were XDRs in COVID in the last year and 23% for the 2021. Acinetobacter baumannii, very high XDR. This data actually alarmed me as well when I looked at it. 55%, 56% XDRs in Acinetobacter baumannii and almost 70% in isolates from COVID patients. Relatively low numbers, very low numbers if we compare to Acinetobacter baumannii in Pseudomonas aeruginosa. We also found this data in the COVID patients in the data that we published last year, where we saw that almost 47% of the patients who were hospitalized and had secondary infections, they were infected with MDROs. And we also documented high mortality, around 66% in patients who had infection with multi-drug resistant organisms. Now, as we all say, the antimicrobial resistance is a direct consequence of antimicrobial use. This is one study which was published in January this year, and it was undertaken in 4 government and 1 private tertiary care hospital. It looked at the data for 1747 patients and 2,834 prescriptions. So what is exactly happening in terms of prescriptions in the tertiary care hospitals? Some of the hospitals which were covered in this study are also part of ICMR network. Now, what we saw was that very high consumption of third generation cephalosporins, which are broad spectrum and from the watch category of the WHO aware classifications. More than 1/10 of the patients received 3 or more antimicrobials, and 7% of the patients, they received double cover for gram-negative organisms, colistin plus meropenem, piperacillin plus tazobactam, and they were just the cover. They were not, there was no indication for prescription of these drugs. These were used more as an antibiotic cover. Similarly, piperacillin tazobactam with levofloxacin. Similar data we also saw in COVID patients when we looked at the hospitalized patients with secondary infections in 10 hospitals, that almost 52% of the antibiotics were prescribed from the watch category of WHO and 22% from the reserve category. Very high usage of BL-BLI, like 57% patients received BL-BLIs. Carbapenems was given to 43% patients, and vancomycin or teicoplanin was prescribed for 24.9% patients. There was excessive use of broad-spectrum antimicrobials. As a result, we saw reduced susceptibility to piperacillin tazobactam, cefpoarizone sulbactam, as well as carbapenems in these. So what is exactly the burden of drug-resistant infections in India? As I mentioned in my opening remarks, that this data is most needed from low middle income countries, but it is least available. Well, we have tried to put something together, and it definitely needs a lot of improvement. But this is one published study which was published a few years back. And this is a 1-year multi-institutional observational study from India using data from a private hospital chain. There were 10 hospitals in this, and they looked at the patient level AST results for Enterococcus, E. coli, Staphylococcus aureus, Klebsiella pneumoniae, Acinetobacter, Pseudomonas aeruginosa, Enterobacter, and they were analyzed for their association with the patient mortality. They looked at almost 5,000 AST results from 10 hospitals. Overall mortality rate of patients was 13%. There was significant association between MDR and mortality. The patients with MDR infections had a 1.57 times higher odds of mortality, and the ones with XDR infections, they had 2.65 higher odds of mortality as compared to similar patients with drug susceptible infections. Infections with MDR and XDR, E. coli, Klebsiella pneumoniae, MDR, Acinetobacter baumannii were associated with 2 to 3 times higher mortality, and similarly higher mortality was also seen with the MRSA Now, this is one study which was funded by ICMR. The study is just got completed, and this is a very preliminary findings that I'm sharing with this group. This study was undertaken in 8 government and private hospitals. One part of study was the retrospective analysis, and one was the prospective data collection. They looked at the incremental cost of treating drug-resistant infections in the patients having drug-resistant infections, and the controls were the patients who were susceptible to the antimicrobials. So what we found in this study, this was undertaken in 8 government private tertiary care hospitals, which are also part of ICMR AMR surveillance network. 4 government, 3 private, and 1 charitable hospital were there. Now, this is one government hospital data which looks at the mean incremental cost. There were 42 cases, thereby meaning resistant patients with resistant infections, and 28 controls which were infected with non-resistant infection. Mainly the pathogens which cause resistant infections were from Enterobacteriaceae, Acinetobacter baumannii, and Staph aureus at 38, 23, and 14%. And the ones which were observed in the controls, which were the non-resistant group, they were caused by Staph aureus, Salmonella typhi, and Enterococcus faecium. So you can see that the profile itself is different between the ones with the resistant than with the non-resistant patients. Mortality among the cases were observed in 50%, and the ones with the non-resistant infections was at 28%. And there was 6,000 rupees increase when the basic treatment for the basic non-resistant Enterobacteriaceae was at 11,000. So this is from another hospital. There was almost the expenditure to treat drug-resistant infection was almost double, and mortality was 32% in the resistant group compared to 26% in the non-resistant group. And in this case, you can also see that addressing the resistant infections also required surgical procedures in addition to antibiotics. Now, this is for one of the private hospitals, and 40% of the patients actually acquired resistant infection in the hospital. It was an HAI, and the cost of treating resistant pathogen was 4,66,000 as compared to 2,55,000 for a non-resistant pathogen, and mortality was 33% in case of the resistant infection patients and 12% in the controls. From the prospective study, they looked at 177 cases and controls. The length of the stay was 12 days for the non-resistant infection and 23 days in the resistant infection. Mortality was 38% in the resistant cases and 28% in the non-resistant cases. Acinetobacter was most commonly observed pathogen in the government hospital, requiring incremental cost, and Enterobacteriaceae was most commonly found pathogen in the private and the trust hospitals. This could do with something with the infection control processes. Then the mean cost of treating drug-resistant infection is 81,000 as documented, and that with the non-resistant infection, it was from the around 50,000. So the mean cost of incremental cost of treating resistant infection in government hospital was 38.7% higher than the non-resistant infections. The cost was contributed by hospital stay, medicines, and antibiotics, and in some places surgical procedures. And both the groups of controls and cases actually had to borrow money to cover the costs of hospitalization. So as we are the largest consumer of antimicrobials, and now there is enough evidence to document that we consume a lot of antimicrobials empirically, and that too broad spectrum. Antimicrobial usage is one of the key drivers of MDRO development in our country. HAIs also contribute a lot to this because we have compromised IPC. So to cover for that, excessive antimicrobial use is there. Now, despite this rapid increase in resistance and widespread acknowledgement, the mortality burden of antibiotic resistance remains largely unknown and still understudied in India. Now, the key pathogens which are of importance are the Acinetobacter, E. coli, Klebsiella pneumoniae, Pseudomonas. They lead to higher mortality rates and also escalated healthcare cost, especially in the hospitals and the acute care settings. Now, to reduce the burden of MDROs and to save lives, we need to improve infection control, diagnostic stewardship, and reduce the empirical use of antimicrobials. We need to really understand the research, which is aimed at understanding genetic and the biochemical mechanisms of antimicrobial resistance, especially the XDR pathogens, promote research on novel therapeutic options, and to support all this, I think there is need to increase the surveillance to all levels of healthcare, and most importantly, quantify the impact of community transmission that it has on hospital infection patterns, and addressing MDROs would require actually investment in all the areas. Just by reducing antimicrobial use, it will not help unless we reduce the infections which are actually happening in our hospitals. And we all know hospital infections are mainly multi-drug resistant infections. So thank you.
Thank you, ma'am, for your enlightening words about the MDROs. So I will ask the participants if they have questions. So we have time for taking one or two questions now. So in the chat box, it is there. Okay, so ma'am, as you have told that after this COVID, the resistance is more increasing as compared to the pre-COVID data which you are showing. So may I know, because that resistance was already there, so what can be the factors where after COVID it is more increasing as compared to the pre-COVID era, though the MDROs were there earlier also?
Sure, but this is what we found in the data. And you also know that patients who were hospitalized because of COVID, some of them had very long stays in the hospital. And to cover for any kind of an infection, they were given sometimes 3 antimicrobials or 4 antimicrobials. So a lot of empirical use of antimicrobials, especially the broad spectrum antimicrobials, has happened during the COVID time. And so that's why I think we are seeing this effect. And also understand that this data is coming from the tertiary care hospitals, where the patients may have come also after taking previous antibiotic treatments. So all this is collectively leading to increasing levels of drug resistance. We saw almost 70 to 80% resistance to piperacillin tazobactam. I'm not sure the things were so bad pre-COVID. But in COVID patients, we are definitely seeing very high resistance rates.
Yes. In our settings also, we are seeing that increase of resistance, yes. So thank you, ma'am, for enlightening us with your knowledge and sharing us with your data and your work with all the participants of today's program. I thank on behalf of the organizers. So thank you, ma'am.
Thank you.
So now we move on to the next talk, that is bench to bedside, integration of microbiology diagnostics in antimicrobial stewardship program. So we will listen to this from a very preeminent, distinguished and renowned personality in the field of antimicrobial resistance. We all know that in this era of translational medicine, it is very important that whenever a microbiologist does anything in the lab, it must get translated to the patient benefit. In context of AMR, it is very important that the report, the antimicrobial susceptibility testing report, which microbiologist is generating, sitting in the lab, so it must get communicated very efficiently to the clinician, and it should facilitate for the clinician's decision in choosing the right antibiotic at the right time for the right patient. So to throw the light on this very relevant topic, we invite Dr. Balaji from CMC Vellore. Dr. Balaji V, he is Professor of Microbiology and the Hilda Lazarus Core Research Chair at Christian Medical College, Vellore. His area of research interest is vaccine-preventable invasive bacterial diseases and antimicrobial resistance and the sepsis. He is the principal investigator for vaccine-preventable invasive bacterial diseases surveillance in the WHO Southeast Asian Research Organization countries. And he is also the PI, National Nodal Center for the Antimicrobial Resistance Surveillance for gram-negative pathogens. He is Fellow for Indo-US Science and Technology and Global Infectious Disease Research Fellow from NIH, US. He has published more than 385 peer-reviewed articles in various journals. So, on behalf of the organizers, I invite Dr. Balaji to please enlighten us with his words about the bench to bedside. Dr. Balaji.
Good evening, ma'am. Thanks for your nice words. Today, for the next few minutes, I'm going to talk about the bench to bedside integration of microbial diagnostics in AMSP. So essentially what it means is I'm going to talk about the roles and responsibilities of a microbiologist to support physician to carry out an excellent antimicrobial stewardship program. So there is a lot of things are there to be done, but whatever it's clinically more relevant and a few tips only can be shared for the next few minutes. I would like to share the following. It's definitely a multidisciplinary integrated approach strategy where to have an excellent antimicrobial stewardship, you need to have a diagnostic stewardship and as well good infection control practice. So even if one link is weak, then the entire chain will be weak. So it is a collective effort. Together, this can limit the emergence and the transmission of antimicrobial resistant bacteria. So essentially, you say that antimicrobial stewardship is a coordinated intervention where you try to achieve to give appropriate drug, appropriate dose and dosing interval, duration, de-escalation, debridement or drainage, and finally I've added the word diagnosis. It both clinical diagnosis and more importantly lab diagnosis. The last one is very important, that is lab diagnosis, because without the scientific evidence, laboratory results, it's very difficult these days to give appropriate drug, because 60 to 70% of the time the individual will be on empirical therapy. So with the empirical therapy, the chances of appropriateness of the therapy may not be that high. So if you have a definite evidence-based lab diagnosis, organism identified and susceptibility profile are done, then it is very easy to achieve targeted therapy. So the last diagnosis and the appropriate drug are very much important in this scenario. So when we achieve all this this is the best clinical outcome can be achieved, and the treatment of the infection will lead to minimal toxicity and minimal impact on resistant development. And you know that even recently, Koloff in critical care medicine 2021, again he has re-emphasized the importance of starting the therapy at the earliest. So in the graph you can see in the bar chart, delayed appropriate therapy increases the mortality in every study. It's very well known and proven. And it's not only the delayed therapy results in mortality, the inappropriate therapy also results in mortality. In addition to resulting in the mortality, you can see here the risk of new antibiotic resistance emergence. So for anyone who are on therapy, antibiotic therapy more than 7 days, you can see that at least 3 to 4% will go for an antimicrobial resistance. And so one important aspect which I am going to focus today is selection of appropriate antibiotic therapy. This will be achieved with best diagnostic stewardship. This best diagnostic stewardship is how good a specimen has to be ordered, how it has to be collected, processed, and which is the best platform to test those specimen, and what are all the various other options, platforms are available to detect the organism. And among detection process, there are two important criteria in the microbiology lab we follow. One is we try to get the result at the shortest time, that is the yearly or the shortest turnaround time with accurate result. So getting an accurate result very late is of no use, and short time result with the inaccuracy is also not good. So these are all the two important aspects which the microbiology handles. Okay, so how early to identify the organism? Nowadays, if there is an affordability and availability of the technology, which can be easily achieved, but the major hurdle in this area, identifying the organism, is ordering for the culture and affordability of the patient and availability of the infrastructure are the most important aspects. But there are technology and systems are available where you can identify the organism at the earliest. Now I will show you that the traditional method is blood collection, then inoculate into the blood culture bottles, then semi-automated machine. Once it flags positive, from the blood culture bottle, what you can do is make a peripheral smear. From the smear, you can identify, gram smear, we can identify the morphology and give the preliminary report. And if you want the confirmed diagnosis, in the same smear, pan fish or quick fish, fluorescent in situ hybridization will almost identify the common pathogens like E. coli, Klebsiella, Pseudomonas, Acinetobacter, Staph aureus. So these are all the 5 organisms. Almost 85% of the time, the patients in the hospital have infection with either it's a bloodstream infection or pneumonia or intra-abdominal or urinary tract infection. Apart from this, multiplex PCR is there, Veregene, MALDI-TOF, Gene Expert, and BioFire. Almost all these platforms are easily available in most of the tertiary care centers in the developed nations, and in India, most of the private tertiary care hospitals. Again, these are all available. If not, definitely MALDI-TOF, Gene Expert, BioFire is available. So within hours, the organism can be easily identified. In case if you want susceptibility, the traditional subculture and overnight incubation from the colony morphology, you can identify through Vitek2, MALDI-TOF. If there is a difficulty to identify the organism, then 16S rRNA can be done. So definitely almost 95 to 100% identifying the organism has been reasonably achievable in today's circumstance. And now what we are focusing more on is even to cut down this time from 72 hours to 24 hours directly from the blood. There are many molecular methods are available where you can identify the organism. To mention a few, Tachman low density array, Roche light cycler, Septifast, Septitest, View, Magiplex, and the T2 Candida. Among all this, the T2 Candida seems to be more robust and more reliable. And you can see the various tests where within 15 minutes to 8 hours, you can identify the organism from the blood culture supernatant. Phenotypically, if the blood culture supernatant is, blood culture is positive, and from the supernatant, you can do the latex agglutination and identify the organism, or you can do the immunochromatography, you can identify the organism, or you can do the Vitek2 ID and you can identify the organism. This is phenotypic. Through hybridization, panfish, quickfish, and Veregene can be done within 3 hours. And again, amplification, Gene Expert, BioFire, Film Card Array, MALDI-TOF, within 1.5 hours, you can identify the organism. Almost all of these are FDA approved. And we are more interested these days to collect it directly from, test it directly from the whole blood. There are many are available, and this is a whole slide. I can show you the much more numbers are in the late stage of getting approval. And most of these kits are approved by the European Union. So hybridization technique, This is the peptide nucleic acid fluorescence in situ hybridization. You can see that you can hybridize with the appropriate reagent and look at the microscope. If it is E. coli, it will show in green color. If it is Klebsiella, yellow color. If it is Pseudomonas, red in color. Or if it is gram-negative organism, it depends upon the probe which you had. Accordingly, the organism can be detected. Now, even for Acinetobacter baumannii, it is there. So almost 85%. Acinetobacter baumannii and Staph aureus also it's there. You can see Staph aureus and Coagulase negative staph also can be distinguished through this in situ hybridization, and for Acinetobacter is also available. For all the top 5 pathogens, easily that can be identified within 20 to 30 minutes. And now we have a next generation ID and the AST platforms. I can run it through quickly. One is the accelerator pheno system, otherwise it's called as time-lapse microscopy. This has really revolutionized the identification of the organism within 2 hours. So it's all it does is when the blood culture is positive, the positive organism grown in the blood culture bottle gets lysed and it gets filtered and immobilized onto the magnetic platform. And then when the probe, it's all automated, one touch go. And when it gets immobilized with the appropriate probe, it shows what organism it is. If there are multiple organisms, multiple color comes, and without any additional steps, automatically this moves to the susceptibility testing. In the susceptibility testing against the antibiotic, if it is inhibited, then there is a loss of growth of the organism. If it is resistant, then the organism starts multiplying. With the growth kinetics, morphokinetics, every few seconds it keeps taking like a PET scan imaging is done. That's why it's called as time-lapse microscopy. Automatically it takes photograph and you can see the tiny dot becoming a large colony. So with the subsequent, like a PET scan, it keeps doing, and then it identifies the growth of the organism, and that all these things achieved within 2 hours of the blood culture positivity with highest accuracy index, that is highest sensitivity and specificity of more than 98%. And the great advantage with this system is not only the identification, it gives MIC for even if 2 organisms are positive by the system, separately for both the organisms, minimum inhibitory concentration for multiple antibiotics, the results are available within 7 hours. It's quite expensive, not available in India, and this is going to be the future promising platform to be available in India. And how this helps to achieve a greater impact on the antimicrobial stewardship program is, you can see from here, from this table, almost all the parameters index have gotten a significant p-value, where the total duration of antibiotic is reduced using the system, duration of intravenous antibiotic therapy is decreased, time to oral therapy is also decreased, duration of anti-pseudomonal beta-lactam days also decreased, length of stay is decreased, readmission alone is 1%, which will be insignificant. So almost every other parameter, it helps to decrease the turnaround time and antibiotic cost of the patient in the hospital. And there are many such things are available in the market. Few are in the pipeline, few are already available in the market. So you can look at the based on the mass spectrophotometer, Bruker, Daltonic, and all instrument providers, where the AST alone is there, which provides MIC. Whereas there are few systems where fluorescent hybridization techniques are used. Here there are 4 different companies are there: ExpressFish, Accelerate Diagnostics, First Light Diagnostics, and ArcDia. Within 4 to 5 hours, it gives ID as well as antimicrobial susceptibility testing report. Here, interesting, it's not the disk diffusion method, it's the broth microdilution, that is minimum inhibitory concentration is given. And this last 2 kits, which are platforms, which are even more popular because in addition to the bacterial, it can also identify the viral. So it's really, in another few days, we can see that no time should be wasted to identify the infecting organism. It's well achieved. So I move on to another area, challenging area, where we, as a microbiologist, find difficult to diagnose the lower respiratory infection, because other than sputum, it's very difficult to get the bronchoalveolar lavage or endotracheal aspirate. And even if you get a good sample, the problem is we find it very difficult to distinguish whether it's a colonizer or a pathogen. So this is one panel which is more promising called BioFire Flumarine Pneumonia panel. Here I can say that this Flumarine Pneumonia panel is a poor cousin of shotgun metagenome, or it can be a stepdaughter of the shotgun metagenome. It's a well thought out concept where for bacteria, semi-quantitative log bins. It gives a quantitative measure where you can distinguish whether it's a colonizer or a pathogen. For all the common bacteria which causes infection in the hospital are listed, nothing has been missed out. All the hospital acquired infections, not the community acquired. Whereas for atypical bacteria, it's only qualitative, not quantitative. This includes chlamydia, legionella, and mycoplasma. And again, qualitative is the viruses, the common virus causing pneumonia. And in addition to that, it also detects the antimicrobial resistant genes for Staph aureus, that is McA-C, or the methicillin resistant REJ gene. I will explain about this in later slide, and CTXM, and the big 5 carbapenemases, KPC, MDM, OXA48, Vim, and IM. So how does it work is, it's very interesting. You can see if it is less than 10 to the power of 3.5, it won't detect, it won't even reveal. It will just hide. So because these are all the colonizers, unbinned values less than 3.5 copies per ml will not be detected, and it will be detected between 10 to the power of 3.5 to 10 to the power of 4.5, and this will be rounded as 10 to the power of 4 copies. Again, between 10 to the power of 4.5 to 5.5, it will be rounded off as 10 to the power of 5, and between 5.5 to 6.5, it will be rounded as 10 to the power of 6. And again, 6.5 to 7.5, it will be 7. So this is how it has been rounded off. And you can see in this picture, with the various dilutions, you can see the bins, 10 to the power of 4, 5, 6, and 7. And the precision is almost 100% except the third one, that is the third dilution. That is 10 to the power of 5. So it can, the sensitivity and the positive predictive value and negative predictive value with the bronchoalveolar lavage, it achieves almost 96.2 to 98.3%, and sputum 96 to 96.3 to 97.2%. And here, if you can collect the nasopharyngeal swab, if you are suspecting only viral or atypical pneumonia, nasopharyngeal swab alone is sufficient enough. If it is a bacterial, then sputum, endotracheal aspirate, or bronchoalveolar lavage is required. For nasopharyngeal swab, even the respiratory panel 2 is sufficient. You don't need to use the pneumonia panel. And the volume we require for test is only 200 microliters, that is 0.2 ml, 0.2 ml. This is more than enough. And you don't need to worry about the quality of the specimen, respiratory specimen. You don't need to expect that more neutrophils should be there and less epithelial should be there, no saliva contamination. All those problems this molecular technique overcomes. And you can see the sample report, how it's given. It gives the log dilution of every organism, and whichever the organism is very high, that is closer to the 10 to the power of 7, you can consider that as a pathogen, and the second one may be a co-pathogen. So that's how you can, and if it is less than 10 to the power of 4, if it is 10 to the power of 5, we call this mild, 6, we call it as moderate, and if it is 10 to the power of 7, then we call it as severe infection. So you can see here, so based on the quantitation of the particular organism, we can assign them the pathogen status. Another example I can give is, here you can see in this report, Staph aureus is positive up to the 10 to the power of 7, and influenza A viral is also positive. So it shows that it's a latent infection or super infection over a viral infection, Staph aureus. So really, this is very helpful. Definitely, you cannot avoid culture. You need to do the culture. In addition to the culture, this pneumonia panel will be very useful as it quantitates the bacteria and also gives the antimicrobial resistant profile. And for two things, this has been very successful. One is it can clearly distinguish the Staph aureus from the coagulase negative staph, because of the target which they use is the MRSA. Staph aureus infection, you can avoid using any gram-positive used. So this is one of the successful story where for antimicrobial stewardship to avoid or to cover gram-positive, this test is very useful. And second one is based on the quantity of the organism you see, you can de-escalate the antibiotics. So that is another great advantage which they have come across using this panel in the US. Care centers where within 3 days you can actually have all the information about the flora, microbial flora in the respiratory tract. I said that pneumonia panel is almost a poor cousin of the shotgun metagenomics. You can identify all the organisms. So now I move on to the susceptibility testing and reporting policy for better AMSP. And IDSA doesn't recommend piptazo for ESBL producers because you know that OXA1, TEM1 hyperexpression, then multiple ESBLs, including the SHIV class C, everything co-expressed. So piptazo may not be a good choice if it is an ESBL. And the Merino trial also has clearly mentioned that there is a methodology issue. The laboratory testing methodology issues are there. So the only exception for piptazo ESBL positive is the uncomplicated urinary tract infection. So if you are following, you need to be clear in your hospital whether you are following this kind of policy. And if you are following this kind of policy, then you need to have a first line panel, second line panel, and what drugs can be there in the first line panel and second line. But so you have to decide, it's an individual decision of the hospital antibiogram, you have to take a call. And same thing happens for Klebsiella also. Piptazo may not be a great drug. And wherever piptazo fails, the cefoperazone sulbactam may not be a great alternative to employ. You need to be a little careful when you say, call it as carbapenem sparing agent. The definition for carbapenem sparing agent is it should have carbapenem activity. That is, the spectrum of cover should be similar to carbapenem, but without carbapenem. So that is called as carbapenem sparing agent. So to make it little simple, you need to know whichever the drug for whichever the panel you are using. It can be a bloodstream infection, pneumonia for a pneumonia, lower respiratory infection, intra-abdominal infection. When you are choosing antibiotic, you should know that how much it covers. If it is a piptazo, it covers both as a cefepime as well as the anaerobic cover. If it is a cefepime, spectrum is similar to ceftriaxone plus Pseudomonas cover. If it is meropenem, it will cover piptazo plus ESBL cover. If it is moxifloxacin, it cannot cover Pseudomonas aeruginosa, but it will have activity similar to levofloxacin plus. Again, it will have a ceftriaxone cover and MRSA cover. Levofloxacin, it will have all three cover, levofloxacin cover, MRSA cover, and anaerobic cover. So you need to have in which panel, which syndrome, which antibiotic needs to be included, you need to know. Now I move on to the critical area. If it is an XDR gram-negative pathogen, it is very important for the microbiology lab to determine the minimum inhibitory concentration and to determine the type of carbapenemase produced, and as well to do the synergy testing by checkerboard method. Why you need to have a minimum inhibitory concentration? Because for a certain antibiotic, it's a mandatory methodology. You cannot have a choice. And for many number of patients in the critical care unit, you need to have personalized choice antibiotic. For that, minimum inhibitory concentration is required. And when you are formulating an empirical antibiotic guideline, I will give you an example why you need minimum inhibitory concentration. And as well as in the same slide, I would like to explain you the minimum inhibitory concentration. How will you show, how it will reveal the emerging resistance. As well, this is required for the synergy testing. So with the XDR bugs seen in that hospital, it's mandatory for that microbiology lab to provide minimum inhibitory concentration. So for this, all the drug microbroth dilution is essential. Vancomycin, colistin. In another few months, we may have already we have ceftazidime avibactam. The other FDA-approved drug, imipenem, relibactam, meropenem, vaborbactam, cefiderocol, is going to be available. So those are all can be determined. Susceptibility will be determined only by microbroth dilution. So that can be easily done. What we will do is we will customize and do it in-house. Prepare the antibiotic panel, freeze it for some time, then we do the seal the panel, and then we store it in the freezer again. As and when you want to use the plate, you can pull out and thaw and then start using the plate. It's very important to determine the MIC 50 and the MIC 90 for two reasons. This is very important. As I told you earlier, it's very important. Without the MIC 50 and MIC 90, you cannot choose the empirical.
I'm sorry to interrupt, sir.
Antibiotic choice.
Hello.
Hello.
I'm
Yes?
sorry to interrupt you. Can we wrap up within another 1 minute, sir?
So that's why you need to have a MIC 50 and the MIC 90. And to know the emergence of resistant, if it is Endium E. coli, you need to have the MIC. And Pseudomonas, again, you can see the microbiologist to be alert that the FDS CLSI may give anything less than 16 is susceptible. But the UCAS mentions 0.001 is susceptible. So when they see this, this is the latest information which they have generated. When the wild strains alone will have this. Otherwise, generally by default, you need to give high dose for Pseudomonas aeruginosa for all these antibiotics. So you need to have the identify the exact enzymes. Unless you know the enzymes, you cannot give appropriate therapy. And there are many number of tests available in the market to identify the exact enzymes. So there are many numbers are available in the market which you have to choose with. It will be detected within 2 hours and with 100% sensitivity and specificity. These are all the kits available in the market for identification at the earliest. Even for OXA23 for Acinetobacter baumannii and for all other variants, it's available. And we do the gene expert, and accordingly we give the recommendation for what enzyme, what antibiotics needs to be given. So this helps for prompt appropriate therapy. And synergy testing, again, for ceftazidime and avibactam and aztreonam, we can do either E-test strips kept like this, or 2 disc, the zone of hope is identified, or you can keep 2 adjacent E-test strip. If you do separately, it will be resistant. If you keep together, then you can see the susceptible. So what I would like to mention here is, at present, if it is OXA48 like resistant to ceftazidime, avibactam has not been reported anywhere in the globally. So you can use ceftazidime, avibactam without testing. And for NDM positives, ceftazidime, avibactam plus aztreonam seems to be very good. No resistance has been reported. Definitely, when you combine 2 to 4-fold MIC decrease is there in vitro for sure. However, you need to be a little cautious about the aztreonam dose, because unless you give 2 grams TID, it may not work. And infusion should be given simultaneously with ceftazidime, avibactam. You need to be watchful about the hepatotoxicity and poor lung penetration. And most important is PB3 insertion in the E. coli and the efflux in the Pseudomonas may not work with the ceftazidime, avibactam, aztreonam combination. So these 3 are the difficult organisms: Pseudomonas, Acinetobacter. With the beta-lactamase inhibitor, you cannot overcome porin loss or hyper-efflux. If it is a non-metallo-beta-lactamase multidrug resistant, then these 3 beta-lactamase inhibitors may work. If it is metallo-beta-lactamase, that's what we see 70% in India. So we have very limited choice. Other than colistin with the carbapenem or amikacin, we have no choice left. So we have to stick to this combination. And this is one of the best slide I put in here. For Acinetobacter baumannii, preferred choices are what we have in India for various infection sites. These are all the recommended panel. Alternatively, we don't have the choice of cefiderocol and eravacycline. So we have limitation, and what to be avoided for what syndrome for Acinetobacter baumannii we have given. So these are all the something like a thumb rule where you cannot change. This needs to be followed as such. Irrespective of the treatment, Acinetobacter baumannii is going to have 40% mortality. And the cascade reporting, suppose if the third generation cephalosporin and beta-lactamase inhibitor are susceptible, don't report carbapenem, colestrin, fosfomycin, or tigecycline. For MSSA oxacillin susceptible, don't report vancomycin, linezolid, or tigecycline. Again, if it is enterococcus susceptible to ampicillin, gentamicin, don't report vancomycin, linezolid, and tigecycline. Similarly, if lower one is susceptible, don't report higher ones. And if carbapenem is resistant, then you report colestrin, ceftazidime avibactam, or ceftazidime avibactam with aztreonam on request. If even colestrin is resistant, then you need to have an synergy testing with combination and tigecycline. So don't give unnecessary information, because once if you start, then it's very difficult to broad spectrum to de-escalate. And the last slide is, for every panel, don't report a fluoroquinolone, because the fluoroquinolone, there are multiple warnings from FDA is there, where it causes hypoglycemic coma, certain adverse mental health, then permanent adverse effect to tendon, muscles, joints, nerves, peripheral neuropathy, tendon rupture, and of the last, most important is aortic aneurysm. And in the United States, you can see fluoroquinolone use has decreased by 36.5%. For respiratory conditions, 78%, for urinary conditions, 31%, and for GI conditions, 30%. You all know that fluoroquinolone and cephalosporin causes huge collateral damage, and it increases the antimicrobial resistance. So to be, you cannot avoid cephalosporin, at least fluoroquinolone can be avoided. Thank you.
Thank you, sir, for your nice words about that bench to bedside and providing us the thorough knowledge about that, how we can quickly diagnose, and for a microbiologist, nice suggestions you have given. Sir, because as we have crossed the time limit, so I just one question we can ask. So Dr. Dhana Shiri, she is asking that when we are using pneumonia panel, as it identifies the organism and gives MIC also, so do we need to do culture again?
Yeah, definitely you need to give the culture because it's not for the test for diagnosis, it gives an adjoint tool to treat. So definitely culture needs to be done, and this pneumonia panel doesn't give MIC. It only gives the resistant gene positivity, presence or absence. So even that may not be reliable, it gives a clue, that's all. So over depending on only pneumonia panel is not good. As I mentioned to you earlier, two important contribution by the panel to the antimicrobial stewardship is, number one is you can de-escalate earlier if there are no pathogens picked up by the molecular methodology, because a lot of false positives is well known to occur. So in spite of that, if there is nothing is present, then definitely antibiotics can be de-escalated. Second one is, it has got a very great negative predictive value for staph aureus or coagulase negative staph. So definitely gram-positive cover can be removed or avoided. So that's another two big help from the pneumonia panel. Apart from that, the gram-negative organism also can be identified among the mixtures to distinguish colonizer from the pathogen.
Thank you, sir. Once again, I thank from my, on behalf of all the organizers for the insightful talk. So we'll move on to the next session.
Good evening, everybody. One of the few situations where we clinicians feel helpless is report on MDR gram-negative bacteria. Now, to enlighten us on this important topic and what is latest on that, we have on treatment of MDR gram-negatives, we have Dr. Senthur Nambi from Chennai. He is a consultant physician at Apollo Hospital, specialist in ID. He has worked as hospital infection control chairperson in Apollo Hospital. He has vast clinical and research experience in infectious disease. He has published over 41 papers and in various journals and has contributed to 2 textbook chapters. He's former secretary of CIDS India and currently is governing council member. And format of the presentation will be case-based discussion. Now I request Dr. Nambi to present his presentation. Yeah, we are not able to hear. Sir, we are not able to hear you. Can you unmute?
Can you hear me now?
Yeah, now we can hear. Go ahead, sir.
Yeah, I hope you're able to hear me now well.
Yeah, we can hear. Go ahead.
Yeah, fine. Thanks for the opportunity, and let me go on with the presentation. One of my favorite quotes of William Osler: "A person who takes medicine must recover twice, once from the disease and once from the medicine." And that applies to any medicine, and more so with antimicrobials that we use. And going on to the topic, the gram negatives in ICU, for which I would have just, I'm a clinician, so I've broadly categorized into what is relevant for me from the clinical standpoint. Enterobacteriaceae, the top two pathogens would be E. coli, Klebsiella, and then we have the non-fermenting gram negatives, in which we have the Acinetobacter pseudomonas, and in the Enterobacteriaceae group, probably I would add Enterobacter, Proteus, Citrobacter, because they all kind of behave similarly most of the times. And then again, the non-fermenters, we would occasionally see the Burkholderia cepacia, Stenotrophomonas, and Elizabeth Kingae. And these will be the top pathogens that most clinicians would see in their ICU practice predominantly. Antibiotic selection, probably I would restrict it to 4 R's. What are those 4 R's? Is the right drug given at the right time, for the right dose, and the right duration. So these would be the 4 R's governing the antibiotic selection. The most important or the tough choice here is to choose the right drug, which involves clinical history, examination, diagnostics, microbiology, radiology. All those things would determine what is the right drug. And then if you choose the right drug, then the other R's, the time, dose, duration, would easily fit in. Having said that, it's very difficult to protocolize antibiotic choices in a big country like India. It's easy to have a protocol for acute myocardial infarction or stroke management or even a seizure management, but antibiotic selection, it's very difficult. Resistant gram negatives, one is ESBLs. You know that it's the predominant enzymatic production, beta-lactamase, from the community among the Enterobacteriaceae. The therapy is whether should we use carbapenems or should we use a beta-lactamase inhibitor like ceftriaxone sulbactam or piperacillin tazobactam. And then we have the carbapenem resistant gram negative or the XDR gram negatives. What would I use? Will I use my polymyxin B or colistin, or do I use a combination therapy, a monotherapy? And going on with case scenarios, this is case number 1, 50 years female who is a diabetic, comes with fever, abdominal discomfort for 4 days duration. Examination, she is conscious, oriented, heart rate on the higher side, blood pressures on the slightly lower side, respiratory rate is a little bit higher. Clinical examination does show right loin tenderness, and other labs would show white cell of 18,000, platelets on the lower side 90,000, urine routine shows pyuria, the creatinine of 1.7. The liver function test does show alteration with elevated alkaline phosphatase and GGT and mild ALT alteration. Lactates are high. So this is a case stem. Diabetic lady with abdominal discomfort and fever. We have leukocytosis, pyuria, and there is altered liver functions. So you would look into UTI, pyelonephritis, or with altered liver functions, we may even think of cholangitis, cholecystitis. Sorry. I can see this quite small. Just ask them. Yeah. Cholangitis, cholecystitis also. Or this looks like more of a pyelonephritis with sepsis syndrome clinically, and pending cultures, what would be the empiric antibiotic for this patient? And probably I could add even more to the list. For example, quinolone would have been an appropriate choice 20 years ago. Aminoglycosides are fine, especially with urinary tract infection. But this lady has a creatinine of 1.7, and it's an exclusive gram-negative antibiotic with no gram-positive cover, so may not be the right drug right now. Piperacillin tazobactam is a decent choice, but you heard it from Dr. Balaji, may not be a very good drug if it is a pure ESBL producer. But let me come to that. What do we do in real life practice? Should we choose ertapenem, which is a group 1 carbapenem, which looks a fairly ideal choice for this situation, because we are looking at pyelonephritis for which we have E. coli or Klebsiella? Or should I use a group 2 carbapenem like meropenem? Yeah, that also seems to be fine. And what about this combination, meropenem sulbactam? Definitely not. There are many such combinations available in Indian market. In short, if your lab cannot test for an antibiotic combination like this, looking for its susceptibilities, then I don't think we should be using. Or should I use a combination of vancomycin plus meropenem? That would be an option, provided this lady had underwent a urologic intervention in the past, where we are looking at covering Enterococcus in addition to the E. coli Klebsiella. So this looks like a community-acquired pyelonephritis where we are trying to target E. coli Klebsiella. So can I use a beta-lactamase inhibitor like piperacillin tazobactam or cefpoarizone sulbactam for my E. coli bacteremia pyelonephritis? I know that that is a practice for most of the physicians in India, even though the current evidence says that we should be using a group 2 carbapenem or a group 1 carbapenem, but most of us have been using that. And this was a study from Spain, which looked into amoxiclav and piperacillin tazobactam for the treatment of abdominal infections, predominantly from the urinary tract and biliary tract. They found that it was good as carbapenems. And when they tried analyzing the data, what they found was when the piperacillin MIC was lower, the outcomes were much better. The piperacillin MIC cutoff is 8. Any MIC which is less than 2, the outcomes with respect to mortality was much better, or rather than when the MIC was closer to the cutoff points. So there is some literature support to say that you may not be wrong by using an antibiotic like piperacillin tazobactam for someone like pyelonephritis, especially for E. coli, because there are a lot of huge cost implications. A drug like piperacillin tazobactam would cost 2,000 rupees per day, whereas meropenem would cost from anywhere from 6,000 to 8,000 rupees per day. We need to keep that in mind while we choose these antibiotics. But the Merino trial, which is the proper randomized control trial in the world of microbiology and clinical infectious diseases, comparing piperacillin tazobactam versus meropenem, the management of E. coli Klebsiella, which was ceftriaxone non-susceptible. Probably this was one of the biggest RCT done in the last decade in the management of ceftriaxone non-susceptible E. coli Klebsiella infection. And this trial was quite striking because the investigators felt that the difference in outcome was quite huge. And in fact, they had stopped the trial in between. The piptazo arm had a mortality of around 12%, whereas the meropenem arm had a mortality of around 3.7%. So we have a real world evidence saying that carbapenem is much better than piperacillin tazobactam for managing patients with E. coli and Klebsiella bacteremia. But again, going into this details, finer details, what was found was the analysis of the per protocol population and patient subgroups did show similar outcomes for both the arms. The 30-day mortality was the one with much difference. The piptazo arm, what happened to these patients at 1 month after starting piptazo or 1 month after starting meropenem, that is where the differences actually came up much more strikingly. It was not at the end of therapy, but nevertheless, this is quite clear. When you're dealing with a high inoculum situation where you have an E. coli or Klebsiella, which is ceftriaxone non-susceptible, upfront for a patient in ICU, meropenem or imipenem, ertapenem would be the appropriate choice. So when we choose a piperacillin tazobactam or a carbapenem in the management of ESBLs, what do we look at? I look at into the local epidemiology, if at all, if you practice in a center where your sensitivities to cefepozone, sulbactam, and piptazole is around more than 80%, perhaps you may be right in choosing that. But any number less than that, it's not an empiric drug for these kind of infections. You look into the clinical status and the patient profile. Am I managing a patient in outpatient or inpatient, where I would still go with a BLI, whereas an ICU patient with sepsis, multi-organ dysfunction or shock, I would use a group 2 carbapenem, and most importantly, look into the patient cost, because most patients in India pay out of pocket. 20% insurance, 80% is out of pocket. So we'll have to keep that in mind. A day cost of meropenem is around 8,000 rupees. So we have to keep that in mind before using that drug. So my practice in community-acquired infection, especially below the diaphragm, is I tend to use a beta-lactamase inhibitor like piperacillin tazobactam or cefepozone sulbactam for less serious infections. For life-threatening infections, I would probably use a group 2 carbapenem like imipenem, meropenem, and then switch down later to ertapenem or a BLI based upon the clinical susceptibility and patient clinical improvement. That is with respect to ESBLs. And going on further, it's a case too. I probably saw this patient around 13 years ago in Chennai, 27 years female who was a Chennai resident who underwent an emergency LSCS at a small Caesar section at a small private hospital. The indication to do cesarean was fetal distress. Nevertheless, most gynecologists would prefer to use a drug like cefotaxime as surgical prophylaxis, even though a cesarean tends to fall in a clean or clean contaminated surgery. The antibiotics were continued post-op. All she had was a Foley catheter and a peripheral IV line. From the post-op day 2, this lady had fever and abdominal pain. Day 3 develops respiratory distress and drowsiness. And that day evening, this lady got shifted to our center, presents to the ER with a tachycardia, blood pressure is definitely on the lower side, shock, respiratory rate on the higher side, requires oxygen, 8 liters to maintain saturation. Clinical examination is quite obvious. There is something happening in the abdomen. There is abdominal distension and it is tense, and the lady is drowsy with no focal neurological signs. So this looks like probably a clean surgery post LSCS. And then there is a sepsis. The source of infection on clinical examination looks like probably from the abdomen. And this was the X-ray. Imagine I told you this was 13 years ago. So probably we are not thinking of COVID looking into this X-ray. This is most likely ARDS, and imaging of the abdomen done from the emergency to the CT scan did show loculated abscess collections posterior to the uterus and then had some peritoneal spillage too. So this looked like a pelvic sepsis. So this lady had a post-LSCS pelvic sepsis and with some pus collection in the peritoneum. In the emergency, I was asked to see, and I had suggested this lady to be started on imipenem and teicoplanin, trying to cover E. coli, Klebsiella, and Enterococcus and some gram-positives. It was a young lady with septic shock and multi-organ dysfunction. And this patient was taken for emergency laparotomy. They did find pelvic abscesses with peritonitis. The source control was done. Day 3, post-op, this patient was kind of recovering well. And this was the cultures that we got, the blood and the pus culture, the peritoneal cultures, the intra-op cultures, plus the blood actually grew Pseudomonas. And this was the resistance pattern. You could see it is resistant to the quinolone, aminoglycoside, the beta-lactams, the 3rd generation beta-lactam, ceftazidime, the BLIs, and all the carbapenems. And imagine a plight of an ID physician like me who's been asked to choose only an antibiotic for this patient. My choice of antibiotic was imipenem plus teicoplanin. And now I have a patient day 3, and I got the choice of antibiotic was entirely wrong. This was 13 years ago. And this patient had a carbapenem-resistant Pseudomonas, both in the blood and pus. And that was a report. But this patient was doing well. So patient came in with a septic shock and multi-organ dysfunction. Day 3, we have a culture report like this, but this patient is off inotropes, off the ventilator and doing well. Why? Because what has been done properly in this case is source control. So this is equally important. especially in surgical patients. It's not about only getting the right drug at the right time. There may be certain situations where doing certain things is much more important than giving the right drug, especially if you're dealing with an abscess or a local focus of infection. For a typical example would be an emphysematous cholecystitis or an emphysematous pyelonephritis. No amount of antibiotic is going to kind of clear the patient. You need source control, either radiology guided or cystoscopic guided, or it should be an open surgery. When you're dealing with a necrotizing fasciitis, antibiotics alone will not work. If you're going to deal with a line infection or a urinary catheter infection, the best thing is to remove the infected device. That's the best thing to do. That's very important to look into source control as an important tool in management of patients. And it is the right thing to do in addition to give the appropriate antibiotics. Going on to the management of treatment of XDRs, that is carbapenem resistant, extreme drug resistant pathogens. In my opinion, this is like trying to rescue a big sinking ship through some small ships. That's how you feel as an ID physician in the ICU when you are asked to manage all these carbapenem resistant infections. What are the strategies that we have in managing these patients? The key is actually infection control. In terms of therapeutics, I could use non-standard antibiotics for which resistance has not yet occurred, or I could use a standard antibiotic like beta-lactam with increased doses so that the PK/PD targets are still achieved, or I could use a combination where I use a non-standard antibiotic like polymyxin, tigecycline, fosfomycin in combination with a standard antibiotic, a beta-lactam, which could be a carbapenem or it could be ceftazidime avibactam. Why would I use a combination therapy? Trying to look into synergistic activity. A typical example would be in the management of endocarditis, where you would use a beta-lactam acting at cell wall, plus use an aminoglycoside that would act at the protein synthesis. That has been kind of extrapolated in the management of XDR gram-negatives, where you could give colistin plus beta-lactam. So the colistin could act as a detergent at the cell membrane, which allows the overcoming of purine channel-mediated resistance to carbapenems. That is one concept why we should be giving combination therapy to prevent emergence of resistance while on therapy, especially when you use polymyxins. But for me, the most practical reason is I don't know what I'm dealing at day 0 when my ICU patient has sepsis. So I need a combination of drugs so that it would at least cover, one of those drugs are expected to cover the target pathogen. So what are the options that do we have for carbapenem resistant pathogens? I still believe that in our country, the top 4 pathogens being E. coli, Klebsiella, Pseudomonas, and Acinetobacter, polymyxins remain one class of drug that is expected to work uniformly well across all the 4 top 4 pathogens. In addition to polymyxins, we need to look into other options like fosfomycin, tigecycline, the newer beta-lactamase inhibitor like ceftazidime avibactam, gentamicin, amikacin, minocycline, and plus the other drugs like nitrofurantoin, cotrimoxazole, quinolones, and chloramphenicol. If at all, if we choose to use a carbapenem, always look into the MICs. The lower the MICs are always better. So any MICs in the range of 8 to 16, probably we can use the carbapenem. It doesn't mean that we should use only meropenem at a higher dose. You can always choose the carbapenem with the least MICs. If the meropenem MIC is 16, the imipenem MIC is 2. Perhaps the add-on agent along with the polymyxin should be imipenem and not meropenem. Choose the carbapenem with the least MIC and use the highest possible dose and try to give us infusion, prolonged infusion of carbapenems. A word on tigecycline. It's a glycyl cycline, probably it's a tetracycline-like antibiotic. It does not cover Pseudomonas, it does not cover Proteus, Marginella, Providentia. Acinetobacter, probably in India, 70 to 80% sensitive. As an empiric monotherapy for hospital-acquired infections, no, and it is not a good drug for bacteremias. So you should know when not to use tigecycline. So where do I use? In carbapenem-resistant E. coli Klebsiella as an add-on agent to a beta-lactam or the polymyxin, combination regimes for Acinetobacter, or when I use tigecycline, it should be always in combination with anti-pseudomonal drug or someone with a severe beta-lactam allergy, but you're expected to cover ESBLs where your aztreonam would not work. In that situation, tigecycline is an option when there is severe beta-lactam allergy. Polymyxins, we've been using it since the year 2009. we were familiar with the use of colistin, but in the last 5 years or 6 years, we are familiar with polymyxin B2. So where do we place polymyxin B versus colistin? Are they similar? I think most aspects they are similar, except for the PKPD aspects. With respect to the spectrum of activity, there is not much of difference between either of those molecules. It is almost 99.99% similar in terms of their expected gram-negative coverage. Colistin being a prodrug, the prodrug is handled by the kidney. So the prodrug to colistin conversion happens in the kidney. So the concentrations of colistin in the kidney is much higher than the concentration of polymyxin B in the kidney and urine. So there is more nephrotoxicity with colistin, whereas the nephrotoxicity rates with polymyxin is slightly less. So the corollary is, if you're managing a urinary tract infection, then colistin should be the drug. But the attainment of steady state, or the individual variability is all much less. The attainment of steady state is much quicker with polymyxin B. So polymyxin B on paper is a better drug in terms of PKPD profile. So someone with a septic shock, where you're looking at carbapenem resistant gram-negative cover in India, then probably you would use polymyxin B. These are concepts on paper. If you ask me if there is a randomized controlled trial comparing these two drugs head-on, the management of carbapenem resistant gram-negatives, no, we do not have. But on paper, polymyxin B appears superior to colistin in terms of PKPD parameters. But with managing a UTI, then colistin is the drug to be given. Fosfomycin, another broad spectrum drug like tigecycline, it does cover gram positives like Staph aureus, Enterococcus. It does cover gram negatives. The typical pathogen that is expected to cover with fosfomycin is E. coli, ESBLs, yes. Carbapenem resistant Enterobacteria E. coli to some extent, definitely. Klebsiella pseudomonas always take with a pinch of salt because the susceptibility breakpoints for Klebsiella has been extrapolated from E. coli. It does not cover Acinetobacter, Burkholderia species bacteroids. It does have in vitro synergistic effect with other group of drugs. So in that situation, fosfomycin is useful. For me, it is not an empiric monotherapy drug because it does not cover Acinetobacter in your ICU. And again, for Pseudomonas, it is not a great agent. Klebsiella may help. But if you're dealing with a carbapenem resistant E. coli pyelonephritis UTI, probably this is the drug to go, especially if you're looking at trying to save the kidney from the effects of colistin. So I would probably see fosfomycin as a carbapenem resistant E. coli pyelonephritis drug. Other indications is a plus or minus option. If you don't have any other safe options, then we could try fosfomycin. Not an easy drug to give in the ICU because it infuses a lot of sodium into the system. But keep that in mind while using fosfomycin. The dose is around 4 grams Q6 hourly per day. Any randomized control trial looking into monotherapy versus combination therapy? Yes, there was one such trial, but this trial did have predominance of carbapenem resistant Acinetobacter. What they found was when they compared colistin versus colistin plus meropenem, it didn't make a difference between monotherapy and combination therapy. In fact, the combination therapy, there were more side effects. So with respect to Acinetobacter, we do have a randomized controlled trial which says that colistin alone is as good or as bad as colistin plus meropenem. And but there was one retrospective study known as the increment study, which looked into the management of carbapenem resistant Klebsiella, and the predominant mechanism of resistance was KPC, Klebsiella pneumoniae carbapenemase. It did find not much difference in the overall therapy between monotherapy, overall mortality between monotherapy and combination. But when they tried to look into the sickness of the patient, when they had a score known as the increment score, people with a higher score were more sicker. So what they found was people with a higher increment score, their mortality was little less when they were given a combination therapy. But this was with respect to Klebsiella and Klebsiella pneumoniae carbapenemase. But what do we see in India is NDM and Oxa. So where do I fit in my combination therapy with carbapenem resistant gram-negative infections? It's an empiric therapy, yes. Toxicities to polymyxin develops. There is nephrotoxicity, neurotoxicity. The polymyxin is sensitive, but MIC is high. Provided you choose to follow the UCAS method, CLSI has dumped polymyxin. There is no sensitivity cutoff for polymyxin. And if the polymyxin cannot reach enough levels, the site of infection, typical example would be an intra-abdominal infections and pneumonia, or when you cannot do a source control, which is going to be delayed for whatever reasons, then we might have to use a combination therapy in the management of carbapenem-resistant infections. Going on to the last case, an AML patient, a 37 years females with 95% blast, has got some perianal complaints, low-grade fever on decitabine, put on empiric piperacillin tazobactam, not responding for the perianal pain, on posaconazole prophylaxis in view of the AML. Patient was empirically added on tigecycline by the hemato-oncologist. The perianal symptoms are better. Now on day 10 of the AML treatment, with the whatever perianal symptoms this lady has had, now has a fever, persistent neutropenia, the procalcitonin is high, the CRP is high. The blood cultures are growing gram-negative, and this is an X-ray with new onset infiltrates, both on the right as well as left. The right side is much more than left. It's not COVID. The blood is already growing gram-negative. So what do I use? And again, you have a plenty of choices to choose with, but what do I use will always depend upon what do you have in your ICU. So what is the organism profile in your ICU? I think that would give the answer. But what we have to remember is this lady is already on tigecycline and piperacillin tazobactam. You have to keep that in mind. This lady did grow Klebsiella in the blood, which was resistant to everything, all the beta-lactams. The carbapenem MICs were high. Imipenem MIC is more than 16. Meropenem MIC is more than 16. Colistin MIC is 0.5, and that is sensitive. So what do I do for this patient? So what we can do is look at the molecular genotype that determines the carbapenem resistance. This was the expert CARBA-R. It picked up OXA48. So we have a Klebsiella, which is carbapenem resistant and is an XDR pathogen. It is sensitive to colistin, but we know this genotype. It is OXA48. So what we can use in this management of this patient is plain ceftazidime avibactam. If it happens to be an NDM, then probably we can give a combination of ceftazidime avibactam plus aztreonam. Pure OXA48, probably ceftazidime avibactam alone would suffice. Where do I fit this antibiotic in the Indian scenario? I would always say we need to liaise with the microbiology to test for its sensitivity in all carbapenem resistant gram-negatives. Even if you do not have access to the genotype, don't worry. We don't need to think about whether it is an OXA or NDM. All of us will not have access to all these molecular tests. So if the lab can test for its sensitivity and say that it is sensitive, then we should use this drug. ESBLs, definitely we should be avoiding, even though the licensing clinical trials was done for ESBL and non-ESBL gram-negatives. CR Acinetobacter, no role. CR Acinetobacter may be of use, but definitely I would not rely upon this drug for that. So where do I fit in? I would fit in for my OXA48, KPC, yes, definitely a good choice, but not a problem in India. For my NDMs or metallo-beta-lactamase, I could use a combination of ceftazidime avibactam plus aztreonam, even though it is a kind of a standard practice now in India and most of the centers in the US, I would still put that as an experimental therapy and not as a recognized therapy in the management of MBLs, because we need to have more data with respect to the combination of ceftazidime avibactam plus aztreonam in the management of NDM infections. As far as OXA48 is concerned, excellent drug. ESBLs, excellent drug, but I don't think we should be using it for ESBL infections. With respect to newer agents against the carbapenem-resistant gram-negatives, I think we have discussed on ceftazidime avibactam. Ceftriaxone tazobactam, I think we should remember that as an exclusive anti-pseudomonal drug. Meropenem avibactam, imipenem relibactam, I don't think it offers anything in addition to what we have already in India, because it does not cover OXA, does not cover NDM. So I don't see a major role for this drug in India, even if it is available in India. Cefiderocol could be the answer for problems with India, or aztreonam avibactam to some extent. If we are going to have cefiderocol, then probably it would be an option in our scenario. But right now, we are left with managing these patients with polymyxins, tigecycline, fosfomycin, and ceftazidime avibactam. So this would be my summary of gram-negative treatment in India. With ESBLs, I would not dump BLIs, but I would always say that a group 2 carbapenem or a group 1 carbapenem is far superior, but I would not be wary of using my piperacillin tazobactam or cefepozone sulbactam, provided the patient is stable. That is where I would place that drug, but carbapenems are definitely the drugs of choice for ESBLs. Empiric CR gram-negative cover, I would still say use polymyxins, pending cultures and susceptibilities. Definitive therapy. I know the organism, I know the sensitivities. Where I'm dealing with E. coli Klebsiella, probably ceftazidime avibactam is a good option, provided it is a OXA producer. I could use a combination of ceftazidime avibactam plus aztreonam, especially if it is an NDM, and then I should ask for my lab to test for its synergy. The synergy is positive, and I can use that combination. The synergy is negative, then this combination of ceftazidime avibactam plus aztreonam will not work for NDM. So in that situation, again, we are left with managing with polymyxins. So if you want me to close my eyes and write a drug for a carbapenem resistant E. coli Klebsiella, Acinetone, Pseudomonas, it's going to be polymyxins. But E. coli Kleb, we have this option of ceftazidime avibactam. Acinetobacter, yes, polymyxins remain the backbone. The add-on drug could be tigecycline, it could be minocycline, or sulbactam. Sulbactam is available in a separate drug in India. The dose would be around 2 grams TDS or Q630. Minocycline, we may have to use a higher dose, 200 milligram BD. So these are options in the management of Acinetobacter. Pseudomonas, it's a tough call. If you're going to have an XT or Pseudomonas, we will have to rely only upon polymyxins. If you're going to have ceftolozone tazobactam available, perhaps it may be a valuable addition in the management of carbapenem-resistant Pseudomonas. But for me, the key point is not the antibiotic in the management of all these patients. Yes, stewardship is important. You need to have diagnostic stewardship. You need to focus on teaching appropriate use of antibiotics. You need to focus on diagnosis, clinical, lab, molecular, microbiology, radiology, your routine blood test, and then not to forget source control, remove devices, have those bundles in place, have horizontal infection control measures, focus on bundles, on prevention of VAP, prevention of bloodstream infections. They are much, much important than looking into the drug that we are going to use in the management of all these gram-negative infections. And this is a problem in our country like India. A drug like linezolid can be bought in the pharmacy without prescription, and that sums up everything. So that is why I again keep on saying that having new drugs is not going to solve the problem in our country. We need to look into mechanisms by which we could use these drugs effectively. Even more, we should focus on horizontal infection control measures in our hospital. That would probably sustain the ICU the long run, rather than any new class of antibiotic that is going to be dished out in the market. I think that's my last slide. Thank you.
Thank you very much for very informative and practical lecture. Now topic is open for discussion. One question from audience, online audience. I'll read out. Do you use ceftazidime avibactam plus aztreonam in patients with NDM, CRE infection and AKI?
Yes, we do use in patients with NDM, provided the synergy for that combination is positive. And yes, we can dose adjust in patients with kidney injury for both ceftazidime avibactam plus aztreonam. They are renally excreted, but it can be given dose adjusted in patients with renal failure. The most important thing in the management is to give these drugs as infusions together. There's no point giving ceftazidime avibactam separately, aztreonam separately, because they are expected to work in synergy. So they have to be infused the same point of time.
Okay. Thank you. Other question is, what percentage of isolates are resistant to synergy of ceftazidime avibactam and aztreonam?
I think if you look into NDMs, I would probably say 50% are synergy positive, 50% are synergy negative with Klebsiella. And with E. coli, probably it can be even more higher, where the synergy is less likely to work for E. coli. The synergy is little more likely to work for Klebsiella. Klebsiella is 50%. So it's a toss of a coin for Klebsiella for the synergy to be positive.
Thank you. Thank you very much for a very nice lecture. With this, we have come to last part of the program. On behalf of organizers and on my personal behalf and my co-chairman, I'd like to thank organizers for giving this opportunity. I thank all the speakers for their excellent presentations of this evening. Thank you very much.
Welcome. Bye.